Welcome to Askprep, your trusted companion for NEET and G preparation. Today we will study about a very important topic of physics, which is thermodynamics, laws and Carnot engine. In this video, we will explore the fundamental concepts of thermodynamics, focusing on the laws of thermodynamics and the Carnot engine. Thermodynamics is the branch of physics that deals with the study of heat, work, and energy transformations. It plays a vital role in understanding how energy is transferred and transformed in various systems, ranging from engines to living organisms. Let's start with the first law of thermodynamics, also known as the law of energy conservation. This law states that energy can neither be created nor destroyed. It can only change from one form to another. In any thermodynamic process, the total energy of a system and its surroundings remains constant. This means that if energy is added to a system in the form of heat, it can do work or increase the internal energy of the system. Let's talk about the second law of thermodynamics. This law introduces the concept of entropy, a measure of the disorder or randomness in a system. The second law states that the total entropy of an isolated system always increases over time. In other words, natural processes tend to move towards a state of greater disorder or randomness. This law explains why certain processes, like the mixing of gases or the melting of ice, happen spontaneously. The second law also implies that it is impossible to convert all the heat energy into work. There will always be some energy that is lost as waste heat, and this loss increases the system's entropy. This concept is crucial for understanding the efficiency of heat engines, such as the ones we use in everyday machines and devices. Now, let's focus on the third law of thermodynamics, which states that the entropy of a perfect crystal approaches zero as the temperature approaches absolute zero, 0 K. This law provides a reference point for the entropy scale and implies that at absolute zero, a system would have no disorder. However, reaching absolute zero is practically impossible, so the third law helps us understand the behavior of materials at very low temperatures and the limitations of cooling processes. Now, we come to a very important application of the laws of thermodynamics, the Carnot engine. The Carnot engine is a theoretical heat engine that operates on a reversible cycle, known as the Carnot cycle. It is based on the second law of thermodynamics and provides a model for the maximum possible efficiency a heat engine can achieve. The Carnot engine was first proposed by the French physicist Sadi Carnot in 1824, and it serves as a benchmark for the performance of real-world engines. The Carnot engine consists of two heat reservoirs, a hot reservoir at a high temperature and a cold reservoir at a lower temperature. The engine operates in four stages, two isothermal processes and two adiabatic processes. In the first isothermal process, the gas inside the engine absorbs heat, Q, from the hot reservoir while maintaining a constant temperature. This heat causes the gas to expand, and the gas performs work on the surroundings. In the second adiabatic process, the gas expands without any heat exchange, and its temperature decreases as it does work. The gas then enters the second isothermal process, where it releases heat, Q, to the cold reservoir, causing the gas to contract. Finally, in the last adiabatic process, the gas continues to contract without heat exchange, and its temperature rises. The key point to understand about the Carnot engine is that its efficiency depends on the temperatures of the hot and cold reservoirs. The efficiency of a Carnot engine is given by the formula eta is equal to 1 Tt, where eta is the efficiency of the engine, T is the temperature of the hot reservoir, and T is the temperature of the cold reservoir. This formula shows that the efficiency of the engine increases as the temperature difference between the hot and cold reservoirs increases. However, the efficiency can never reach 100% because some energy will always be lost as waste heat. The Carnot engine is an idealized engine, meaning that it assumes no friction, no energy loss, and perfect insulation. In real-world applications, the efficiency of any heat engine is always lower than that of a Carnot engine due to factors like friction, heat losses, and imperfect materials. Now, let's understand how the Carnot engine helps in understanding the efficiency of real heat engines. In practical applications, engines like those found in cars, power plants, and refrigerators are based on the principles of thermodynamics. However, these engines are not perfect, and they cannot achieve the ideal efficiency predicted by the Carnot engine. Real engines suffer from various losses, such as friction, heat loss to the surroundings, and the need to dissipate waste heat. For instance, in a car engine, fuel combustion generates heat, which is converted into mechanical work to drive the vehicle. However, a significant portion of the energy is lost as heat through the exhaust, cooling system, and friction in the engine components. While the Carnot engine is an idealized model, it helps us understand the theoretical limits of efficiency and the factors that influence the performance of real engines. These systems operate on the principle of heat transfer, using a refrigerant to absorb heat from a cold space and release it to a warm space. The efficiency of these systems is governed by the same thermodynamic principles that apply to the Carnot engine. In conclusion, thermodynamics is a key area of physics that helps us understand the behavior of energy and heat in various systems. The laws of thermodynamics, particularly the first, second, and third laws, provide the foundation for understanding energy conservation, entropy, and the limitations of energy transformations. The Carnot engine, though theoretical, gives us a model for understanding the maximum possible efficiency of heat engines and serves as a benchmark for evaluating real-world engines. As you continue to prepare for the NEET exam, it is essential to understand these concepts deeply, as they form the basis for many applications in science and technology. Thank you for watching this video on thermodynamics, laws of thermodynamics, and the Carnot engine, brought to you by Askprep. Stay tuned for more physics content as you prepare for your NEET exam.